Hello, and welcome back to Chapter 4.6, Rational Functions. This is Part 2, and our objective is still to find domain, asymptotes, and graph rational functions. In this Part 2, if you haven't watched Part 1, go ahead and watch Part 1 of this video. And in Part 2, we're going to graph rational functions. Okay, there are 6 steps to graphing a rational function. And we'll go over those. So step 1 is find the domain. Remember that is setting the denominator function equal to 0. Step 2 is find intercepts. Okay, that's x and y. So for the y-intercept, we'll say f of 0. And for the x-intercept, that's where we set the whole thing equal to 0. Step 3 will be to find any holes. Now remember, what creates a hole, okay, is when I reduce something. In this example, x squared minus 4 over x plus 2, I factor it out, and notice how that cancels with that. Well, that x cannot equal negative 2 creates a hole. So whatever cancels will create a hole. Step 4. Is find any asymptotes. Okay, that's vertical, horizontal, and slant. Step 5 is find additional points. And step 6 is sketch. Okay, so these are the 6 steps that I want to see outlined when you do these types of problems. Okay, so keep this handy, and we'll kind of come back to it as we're graphing these. Okay, so our first example is graph that. So let me switch to a pen here. So our step 1 said find the domain. Okay, so step 1. Find the domain. So I'm taking this x squared minus 4 and setting it not equal to 0. Okay, this is where the problem occurs. I can't have a 0 down there. So this is a difference of squares. So I have x plus 2. X minus 2 cannot equal 0. So x cannot equal plus or minus 2. When we write the domain, we write it as an interval notation. Okay, so we start with minus infinity to minus 2, union, minus 2 to 2, union, 2 to infinity. And there's my domain. Step 2 said find any intercepts. Okay, so for our y-intercept, that is when x is 0. So we want to find f of 0. So I'm just plugging in 0 for these x's here. 0 over 0 squared minus 4. So that's 0 over minus 4, which is 0. So I'm at 0, 0. For the x-intercept, we take f of x equal to 0. So we'll have x over x squared minus 4 equals 0. And we're going to solve that. Well, if I take this, if I multiply, because I got this division here, I have to multiply the whole thing by x squared minus 4. That cancels that. 0 times that goes away. So you have x equals 0. So same thing here, which just tells you that it crosses the origin. Okay. So step 3. Step 3 was to find any holes. That's where it cancels out. Well, again, if I take my function and I factor it all the way out, okay, you can notice that nothing here cancels. Okay, so I don't have any holes. So there's no holes for step 3. Step 4. Step 4 is to find any asymptotes. Vertical, horizontal, and slant asymptotes. Okay, so this is probably going to be the more difficult part. So we'll look at vertical first. So remember, for vertical, we looked at the reduced function, and whatever is on the bottom, that creates a vertical asymptote. Okay, so x cannot equal, so x equals minus 2 and positive 2 are your vertical asymptotes. Horizontal. Okay, with horizontal, you have to look at the degree of the top and the bottom. So the degree of the top is 1, so the numerator is 1, and the denominator is 2. Well, if the numerator is less than the denominator, okay, we're going back to this sheet right here. If the numerator is less than the denominator, you have y equals 0. Which it is, so here's your vertical. So y equals 0 is your horizontal asymptote. Step 5 is additional points. Well, I can't really see what additional points I need until I start sketching things out. And step 6 is sketch. So we'll sketch down here. Okay. So we first want to mark out my step 4, my asymptote. So I have vertical asymptote at minus 2. So 1, 2. So I have this line that I cannot cross. I approach it from one of these directions. And I also have one at positive 2. Okay. I have a horizontal asymptote at y equals 0. So right there. Now my graph's going to be in one of these 6 areas. Or not one, but they're going to be in 6 of those areas. Okay. So I need to figure out where. Now I know that I have a point at 0, 0. So that's one point that I know. Okay. But I need to know where at in here. It is also. So that's where I'm going to pick some additional points. So I have this window. Now I want to pick a number over here. Okay, so we pick -3. If I come up here to the original and plug in -3, okay, just plug it into the calculator, you're going to get -3/5. Okay, so -3, -3/5. So there's 1. So we're about here. So that tells me that my graph, since this is an asymptote and this is an asymptote, I'm approaching this one, but then again, I'm approaching this one. So we're over there somewhere. I'm not up in this quadrant. It can't be because it won't be a function then. Okay, so here, I know I cross here, but do I touch it? Do I bounce it? Do I go through? How do I do that? So we're actually going to pick 2 points in this quadrant. Okay, we're going to pick -1 and 1. Again, plug it back into the original, and you will get 1/3 and -1/3. So I'm at -1 1/3 and 1 -1/3. So this tells me that I'm actually crossing through here. So again, this is an asymptote, so I'm coming from that, going here, kind of like an x to the third, kind of hard to see, and then I'm approaching that one. Again, arrows on that. And then here I need to see if am I in the top or the bottom. So we'll plug in 3 there, plug it in, I'll get 3/5. So I'm actually up here, so 3/5. So again, I'm approaching that one. I come down here, go through that point, and I approach this one. And there's my graph. Now, we can definitely check this on the graphing calculator. So I have x over, and I like to put the top and the bottom in parentheses. That way I can't mess it up. X squared minus 4. And we'll zoom standard. And then we can kind of see here that this matches this. We're approaching 0. We approach 0. We approach -2. Approach -2. Go through 0, 0 down here and down here. So definitely use your graphing calculator there to help assist you with checking. Okay, so we're going to do the same thing with this function. So step 1 is domain. So we take the bottom and set it not equal to 0. So again, this is a difference of squares. So you have x plus 1, x minus 1 does not equal 0. So x cannot be -1 and 1. Now, a lot of times that ends up being either a hole in your graph, or like the other one, it became your vertical asymptote. Step 2, or find the intercepts. So we have our y-intercept. Okay, so I'm just plugging in 0 to here. So you have 0 to the 4th minus 0 to the 3rd minus 6, 0 squared over 0 minus 1. Well, this whole thing turns to a 0. So you have 0 over -1, which is 0. So again, we cross the origin there. And for our x-intercepts, we take the top equal to 0. So x to the 4th minus x to the 3rd minus 6x squared equals 0. So I got a greatest common factor there. So I've got x squared minus x minus 6 equals 0. X squared, factors of 6 that subtract a 1, that's 3 and 2. X, signs are different, the bigger one's minus. So then we have set each one of these equal to 0. So you have x equals 0 multiplicity of 2. Okay. And the reason that multiplicity is important is because that tells me it bounces off. So that will be important for graphing. X equals 3 and x equals -2. So x-intercept, we're just taking this top. Because I multiply both sides by this, and I set it equal to 0, so that's 0 times that, so it cancels each other out. So step 3 is find any holes. So that means we're going to completely factor this whole thing. So I factored the top right here. So x squared, x minus 3, x plus 2 over, that's a difference of squares right there, x plus 1, x minus 1. So as we can see, nothing here cancels. So again, there are no holes. So we'll go to step 4. And step 4 are asymptotes. So we'll look at vertical. Okay. So vertical is this bottom part in the reduced fraction. Okay, since this is all the way reduced, we have x equals -1 and 1 as your vertical asymptotes. Horizontal. Okay, the degree of the top is 4, and the degree of the bottom is 2. Well, when the top, we'll come back here, horizontal asymptotes, when the top is bigger than the bottom, there is no horizontal asymptote. So none. In slant, remember in slant, they have to differ by 1. Okay, well, those differ by 2 degrees, so there is none. All right. Step 5. Additional points. So we'll kind of outline this X, Y here. We'll fill in some of those here in just a second. Step 6. Sketch. Okay, so if we start sketching, I like to start at the asymptotes. So I have vertical asymptote at -1 and +1, and I don't have any horizontal asymptotes. Okay. We know that x equals 0. So I've got 0. 3 and -2. So -2 and 3. Okay. But now I kind of need to figure out, well, how's it work over here? I know it bounces here, but does it bounce it up or does it bounce down? And how's it pass through that point? Okay. I know it passes through because these both had a multiplicity of 1. So it passes through. I need to know, does it come here and up or does it come here and down? Okay. In order to do that, we just have to pick additional points. So I might pick -3 as a point over here. And if I plug that in up here, okay, we get 6.75. So I'm at -3, 6.75. That's 5, 6, so somewhere up here. So that tells me that I'm coming this direction and I'm approaching this line here. Okay, so we're coming here and we're approaching that line there. Okay, and this end just keeps going out. So then I want to pick a point in here. So we might pick -0.5. If I put -0.5 in up here, I get 1.75. Again, I'm just doing that on the calculator. I'm just typing it in. Okay, so I'm at -0.5, 1.75, so about here. So I know that it bounces up there. So we're looking something like this. Okay, and over here I might pick 1, 2. And if I plug that in, I get -5.33. So 2 minus 5.33 about here. So that tells me we're approaching from this side, and we're going up like that. Now again, I could have picked a point over here, okay, just to make sure it doesn't go, it shouldn't go back there because it wouldn't be a function. But just to make sure, you might pick, I don't know, 4 there or something else. Again, let's check it out on the calculator. So you have x to the 4th minus x to the 3rd minus 6x squared divided by x squared minus 1. We can kind of see we approached here, we bounced here, and we went up that way. Okay. All right, a couple more here. So again, step 1 is find the domain. So we take the bottom and set it not equal to 0. All right. So we'll add that to the other side. So 8 cannot equal x to the third. Take the third root. So you get 2. So x cannot be 2. All right. So now step 2. Step 2 is find the intercepts. So we'll look at y. Okay, y, we're just plugging 0 into everything. So I got 0 here, 0 here, 0 on the top. Over, that's 0, so 8, which is 0. So your y-intercept is 0, 0. But we need to write this domain right. Negative infinity to 2, union 2 to infinity. Forgot about that. So the x-intercept, we just look at the top portion. So 4x to the third plus 10x squared minus 6x, and set it equal to 0. And factor, I got to factor all this out. So I got a common x here. So I get 4x squared plus 10x minus 6. Looks like I got to do the rainbow method here. So I can take 4 times 6 and get 24. I need factors of 24 that subtract to 10. So what is that, 12 and 2? Okay, break down this one. You get 2 and 2, 4 and 1, 2 and 3, 1 and 6. So I'm trying to get 12. So I'm going to say 2 and 2, 1 and 6. So then we have 2x, 2x, because your 2 times your 6 gave you the 12. Your 2 times the 2 gave you the 2. So 2x, 2x, 2 times the 6, and 2 times the 1. Signs are different. The bigger one's positive. So I have a plus 12, which was 6, and a minus 2 there. Now, we notice that I can reduce this one also. Okay, up here I could have pulled out a 2. Okay, so we'll pull out this 2 here. That changes, and this changes to a 3. Set each one equal to 0. Okay, so you get x equals 0 there. You get x equals add 1, divide by 2, a half, and x equals minus 3. Again, all those have a multiplicity of 1. So we know that when we graph, that it passes through those lines. All right, so step 3 is any holes. Okay, so in order to find out any holes, we need to factor both the top and the bottom. I did the top up here. So it's 2x, 2x minus 1, x plus 3. And to do the bottom here, we first want to factor out a negative to give me x to the third minus 8. And you should notice that that is a difference of cubes. So I factor that, x minus 8, or sorry, x minus 2. It's the same, opposite, add. Okay, so square the first, multiply them together, square the last. So I have negative x minus 2, x squared plus 2x plus 4. Okay. Is there anything to cancel? No, there's no common factors, so again, no holes. We won't have an awful lot of holes on these types of problems, but you can. A lot of times we give you prime rational functions, so we don't really have to deal with it. Step 4 is asymptotes, so we'll start with vertical. Your vertical asymptote is where the bottom is equal to 0. So we just kind of come back up to here and we set that equal to 0 and we found that it couldn't be 2. So x equals 2 is your vertical asymptote. Horizontal asymptote, okay, the degree of the top is 3 and the degree of the bottom is 3. So when they are the same, it's your leading coefficients. Okay. Now the leading coefficients are 4 and minus 1. Okay, because this is your highest exponent. So you have 4 over minus 1, which y equals minus 4 is your asymptote. And slant, well, since they have the same degree, they're not differed by 1, so there is none. Step 5 are additional points. So we'll just kind of outline an XY here because we will use that. Step 6 is sketch. Okay. So again, I have a vertical asymptote at 2. So I've got this asymptote here. I got a horizontal asymptote at minus 4. Okay. I cross the x-axis at 0, a half, and minus 3. Okay, so now we need some additional points. I got to kind of figure out what's going on over here. Okay, so I might start here. I know I'm approaching this, but which direction am I approaching it is what I got to figure out. So I might pick 1. If I plug 1 in way up here, we will get 1.14. So 1.14. So I know I'm approaching this way. Okay. I might find out, it's kind of hard to tell what's going on here. So I might put in a 4th. If I put in 1/4 into this equation up here, again, you're just plugging it into the calculator, you get minus 0.1. So that means I'm below this. So I come here and I dip below and I'm coming back. So here, I'm also, since I'm passing through, I'm going to have to pass through here and kind of go this direction. So it kind of tells me, without picking a lot of extra points, using the multiplicities of this, I can kind of tell what's happening. I know that I got to come from here, I'm passing through, and I'm approaching that asymptote. Now here, I don't know if I'm up here or down here. Okay, so in this case, we'll plug in, let's say 3. If I plug in 3 into this up here, just put it into the calculator real quick, you get minus 9.47. So at 3, 1, 2, 3, I'm at minus 9.7. So that tells me I'm down here somewhere, about there. So I still have this vertical asymptote, so I'm approaching here, and I'm approaching here. Again, this is just a sketch. These aren't exact, Okay, if we plug it into our calculator here, we get 4x to the third plus 10x squared minus 6x divided by 8 minus x to the third. Graph. So again, we're approaching here. We go up, down, up, and then we come back down there. So very, very close to my sketch, and that's really all I want. I want it close. All right. Again, step one is domain. So take the bottom, set it not equal to 0. So x cannot equal minus 2. All right, so I have negative infinity to minus 2 union to minus 2 to infinity. Step 2, our intercepts. So y-intercept, I plug in 0, 0, I got minus 4. 0, I got 2. So I have 0, comma, minus 2. For x-intercept, we set the top equal to 0. X squared minus 3x minus 4 equals 0. We need to factor that. Factors of 4 that subtract a 3. That's 4 and 1. Signs are different. The bigger one is negative. So x equals 4 and minus 1. Step 3. Our holes. Okay, so we got to factor the top and the bottom. We just did the top. So x minus 4, x plus 1. The bottom is x plus 2. So nothing cancels. If something cancels, that's where I would put a hole there. Okay, so no holes. I'd come down to my graph and I'd just put a little open circle there. Step 4. Our asymptotes, so we'll start with vertical. Okay, so since there's no holes, this is reduced all the way. This minus 2 here, creates a vertical asymptote. So x equals minus 2 is a vertical asymptote. Horizontal, okay, since the degree of the numerator is bigger than the degree of the denominator, we will not have, sorry, come back here. Numerator bigger than the denominator has none. Slant. Okay. Now, since the numerator has a degree 1 bigger than the denominator, I have a slant asymptote, so I have to do the division. Okay. So long division here. So x becomes x squared. That's an x. So x squared plus 2x. Subtract. That's minus 5x minus 4. So minus 5. So minus 5x minus 10. Subtract. Cancel. You get 6. So you get plus 6 over x plus 2. Now, I don't care about the remainder. So my slant asymptote is y equals x minus 5. Step 5 is additional points. So we'll leave that there. And step 6 is sketch. Okay, so vertical asymptote at -2. Okay, there's that. I have a slant asymptote at y equals -5. So I got -5, and I go up 1, right 1, or down 1, left 1. So I've got this asymptote here. So I need to figure out which portion I'm in. So we'll keep going with our X-Intercepts, 4 and -1. Okay, so that tells me I'm in this portion. Okay, I also have a y-intercept at 0, -2. So there. Okay. So that tells me I'm approaching here, and then coming back and approaching there. That's that portion. Now, I got to figure out, am I in this section, or am I in this section that I didn't really graph down here? Okay. Well, all I have to do is pick an additional point. So let's say I pick, I don't know, let's just pick, this is what, -2? So let's pick -3. At -3, I'm at -14. So that's here, that's way down here. So I'm in this quadrant way down there. That's kind of off my graph. So if I plot this one, clear out, I have x squared minus 3x minus 4 divided by x plus 2. There's that one right there. And then this one didn't show up because it's too far down. So if I go to my window and maybe move this to -20, oh, right there it is. So there's that portion, and then there's that portion. Okay. And then you have your vertical asymptote here, which we can't really graph. I could graph the line there, x minus 5. I could graph that, and you can see my asymptote right there. Okay. I think we'll stop there. I only have that one left. If you want to try that one out and see what you get, we can discuss it in class if you would like. And then the second part of your suggested problems is right there. So make sure you give those a try. This is 27 through 33 odd, so that you can check in the back of the book. As always, I appreciate you watching the videos. If you want to like and subscribe, maybe add a comment, that would be appreciated. As always, this is at THS Mr. Jones signing off.